Hello, folks. We're going to go ahead and start talking about data toss. This time, this is an experiment that you guys will be participating in. So, in data toss, we're going to be using the word hypothesis, which is a possible answer to an investigative question. Quantitative, notice how there's the N in quantitative that can stand for number, which are observations which involve numbers and measurements. Qualitative, and notice how I say emphasize the L in that one for look, because they are observations that describe qualities such as shape and color and not measurements or numbers. So things you can sense with your five senses. We also have the scientific method, which is a series of steps that scientists follow. We have observations, so making sense of something by using our senses. Sample size, the size of a group used in an experiment. A control, the variable that's kept the same to compare to the tested variable. Variables, which are the factors in an experiment. Reproducible, an experiment that can be repeated. So first thing that you're going to want to do is get your worksheet out and have that ready to start writing in, because we're going to start actually planning our experiment. So what does make a good experiment? Maybe previously you've heard used mad scientists, very creative robots, as a way to remember what each part is. So M stands for multiple trials, S stands for sample size, V stands for variable, C stands for control, and reproducible is the robots. So first thing that you're going to do is you're going to take a second and pause the video while you write down our investigative question we are going to figure out. Okay, so when you write an investigative question, you usually try and use the form, how does blank affect blank? So this uses that form as well. How does catching a ball with one versus two hands affect the ability to catch? So you guys might have experienced this if you play basketball, where trying to catch like a basketball one-handed might be more difficult for you versus using two hands whenever you're trying to catch the basketball. Um, Same thing if you play like softball or soccer or any of those other things where you have to be able to catch. So we're going to actually explore this idea. So go ahead, take the video and pause it as you copy down the hypothesis. So in the hypothesis, you're going to notice that I think that if I catch the ball with one hand, I will catch it. And you need to decide if you would catch it more with one hand or less times with one hand than I were to catch it with two hands, because blank. A hypothesis is always what what you're guessing is going to be happening in the experiment. So it uses a form that says, I think that blank, and you say what you think will happen if I, and then you say what you're changing, and then you say because, and you have to give a reason why. So why do you think that might be the case? So if I were to say, I think that it is harder to catch a large basketball with one hand than a ping pong ball, because the basketball is going to be larger than your hand and therefore be harder to catch. I gave a reason why. All right, the next one is the control. So a control is what we compare to. How do we know if a change has even happened whenever we change something? So our change is our one and two hands. So we have to pick one of those to kind of be like our normal. So our normal for this experiment is a two-handed catch. Go ahead and write that down. It's two-handed catch because that's normally how you catch things whenever you're playing catch. So that's our most normal. So that's what we're going to use as our control. For the next one, you need to think about constants. So you probably heard a teacher say, "You are constantly talking," or my parents are constantly texting trying to figure out where I am, or things like that. Constant means all the time the same thing. So, some of the constants in your experiment are going to be the distance from your partner. So, you don't want to have the problem of throwing the ball between the two of you whenever you are different distances apart. So, if you do this out in the hallway, you are going to need to make sure that you are the same distance apart. And one of the ways to do that is by looking at the squares that are in the floor and using those squares to kind of help you out, figure out the distance and keep that same distance so you don't get closer and further away, because that's not fair. You're going to be tossing underhand with your partner, no overhand. We're not, because if you're sometimes you're throwing it overhand and sometimes underhand, that's going to have a difference in your experiment. So I am telling you underhand only. And you need to do the same force. The idea is not for your partner to not catch it. The idea is for your partner to catch it. So make sure you're throwing it away, that it's possible to actually do the experiment. Can you think of any other constants, things you're going to have to keep the same? If we were talking about testing outside, we'd have to make sure that the weather is the same. So, like the amount of wind and everything else. So, there's a lot of things to try and keep the same. So, the next is the independent variable. And I want you to think about what is it that's going to be different. So, if our normal is the two-handed catch, what's going to be our independent variable? The one-handed catch. So that's going to be our different sort of thing we are going to test. So because we're catching it with one hand, what do we expect to be different? The number of times that you catch the ball. All right. So that is our dependent variable, because our dependent variable depends on what we do to our independent variable, and it is our outcome. So the next thing you need to write down is what you're going to need in order to actually do this experiment. If you're using the squares in the hallway, you probably won't need the measuring tape, but you will need a ball, a partner, your paper, a pencil, and your journal. So please write those down as the materials you're going to need. So the next part is your procedure. And as you go to write your procedure, it's important that you do something. A procedure is a set of steps that you do in order to say what you're going to do first, second, third, fourth. And you have to be very specific because we want our experiment to be reproducible. That means that we want to make sure that the experiment can be done again in the exact same way. So I might write 1, stand 1 square or hallway square apart from your partner. Step 2, toss the ball underhand to your partner that will catch with 2 hands. And then you say specifically what you're going to do next. Now, I'm going to leave the rest to you to try and figure out. Now, how many times do you think that we're going to do this? Well, if you look at your paper, you can probably guess. So if you look at your paper, you're going to notice that there are boxes down here that you are going to be testing 20 times. So you're going to test 20 times for your control and 20 times for your one-handed toss. So just to kind of help me keep things in my brain straight, one of the things I do is I put a 2 up here for two-handed to remind me that's the two-handed, and a 1 down here for one-handed to remind me there. So you have two types of data that you're going to take. You're going to take qualitative data, which is up here, and you're going to take 4 pieces of qualitative data, so things you notice, and you're going to take quantitative data down at the bottom where you do your X's and O's. Every single time you catch the ball, you write an X, and every single time you do not catch the ball, you write an O. And you're going to do that for the two-handed one, and you're going to do that for the one-handed one. All right, so that's where we're going to stop for right now. Make sure that you have all of your different pieces filled out before you go and test, and then you can raise your hand and talk to your teacher. Have your teacher go over and check your work.